Welcome to another episode of Practical Advanced C++. In this video, we're going to have a look at signals. Signals are a communication mechanism between a process and the operating system. When a running program encounters a significant error, the OS sends a signal to the process. Some processes may have a signal handler, which does some important tasks before the process leaves the CPU. There are various types of signals, each corresponding to different event. Let's have a look at some of them. The first one is signal illegal. In the Unix-like operating system, is sent to a process when it attempts to execute an illegal, malformed, unknown, or privileged instruction. Segmentation fault signal. This signal is generated when a process tries to access a memory location which is not allocated to it. The following are some typical causes of segmentation fault. 1. Attempting to access a non-existent memory address. 2. Attempting to access a memory that the program doesn't have the right to. 3. Attempting to write in a read-only memory. When you access an array index, C and C++ don't do bound checking. Segmentation faults only happen when you try to read or write to a page that was not allocated, or try to do something on a page which is not permitted, for example, trying to write on a read-only page. But since pages are usually pretty big, usually around few kilobytes, it often leaves you with a lot of room to overflow. Let's have a look at the following program. Here we have an array of size 5. If we try to read or write beyond the size of the array, usually we don't get an error. This is due to the fact that we are still in the same page, but this could be dangerous. If we add the address sanitizer to the CMake flag, we can quickly spot such failures. Okay, let's compile our program and run it with the address sanitizer. As you can see, if you run the program, you can immediately spot where the error is happening. The next one on the list is signal abort. I talked about abort, exit, and terminate in my other video. If you want to learn more about abort, please have a look on this video. An error itself is detected by the program. Then this signal is generated using a call to abort function. This signal is also used by a standard library to report an internal error. The assert function in C++ also uses abort to generate this signal. The next one on the list is signal termination. The SIGTERM signal is a generic signal used to cause program termination. Unlike signal kill, this signal can be blocked, handled, and ignored. It is a normal way to politely ask a program to terminate. The shell command generates SIGTERM by default when you press Ctrl+C to terminate a program. Alright, now let's have a look how can we handle a signal. The first thing that we need is to implement a function like the following. It is pretty straightforward and simple. Now in your main, you have to call signal API with your favorite signal, for instance, signal term, signal abort, or any of them with your function. Okay, let's implement some example. In the following, we have a signal handler for signal interrupt. Let's call it SIGINT underline handler. Now in the main, we register the signal SIGINT with our signal handler. Now let's implement a while-true loop. Inside of the loop, we are just waiting for a signal, and we sleep the thread for 1 second. This will continue until you press Ctrl+C. If you run the program and press Ctrl+C on the keyboard, the signal handler will be activated. You can actually comment the exit command and see the program will continue even if you press Ctrl+C. Alright, now let's write a signal handler for segmentation fault signal. Here in the segmentation fault handler, we print a message before terminating the program. Alright, now let's register it in the main and let's cause some segmentation fault. As you can see, before terminating your program, it will print our message. Now that you learn how to handle a signal, you can actually raise a signal yourself. To raise a signal, we call the API raise with the signal number. Okay, for instance, let's implement a function for handling SIGTERM signal. In this function, we are just setting some global variables. We register the signal handler in the main, and then we call raise SIGTERM. As you can see, the value of the global variable before and after calling the raise has been changed. Alright, that was it for today. If you enjoyed this video and you learned something new about handling signals in C++, please do not forget to like this video and subscribe to my channel. It would really help to grow my channel and provide you with better content. Thank you.